quadratics today, which we did a little bit yesterday straight from your calculator, and that's what the first one is doing. So if you want to go ahead and get that going on the calculator, I think some of you did. That would be a good idea. So we're just going to graph this and talk about it a little bit and then do some more. So let's see. We're graphing y equals 2x squared minus 9x plus 2. You already type that in your calculator? So we get the graph, and then, gosh, I hate the lights. They're reflect on here. You can't see a thing. How are we going to get the graph from our calculator onto our paper? Find good points for your table. So Control T is going to pull that up for you, and we just need good points that we can plot. So what are some good ones? What do y'all see? 1, -5 will be a good one. 0, 2 is probably a pretty good one for us. If we got a -1, it's all the way up to 13, so you can't do further than that. 2, -8 would work. What else do y'all see? We could do 4, -2. Is there anything for 3? 3, -7. Let's get that going. For 5, we could do 5, 7. Anything else? I think the rest is off of our graph, which is okay. So we've got all these points. What shape do we know that this graph is supposed to take? That U shape. What's the fancy word for it? Parabola or parabola. So when you're connecting your dots, just make sure that you make it as curved as you can. So we got that nice U shape going on. Mine's kind of ugly, but it's okay. So yesterday we talked about all the different things that you can find from here. We talked about roots. Do you remember what those are? Where you cross the x-axis. What are other words we use for that? You can call them roots or what? X-intercepts or zeros or one more starts with S. Solutions. Yeah? So zeros, roots, solutions, x-intercepts. They're all the same thing. Where do you think those are happening here? I think it's hard to tell exactly what points, but we've got 2 of them. Do you agree? Here and here? Yeah, so I'm just going to, let's say they're about here and here. I'm going to draw arrows and say that those are our roots. Then yesterday we also talked about your vertex. Do you remember what that is? Where it turns, your turning point. So ours is down here. And what would we call that? A minimum or a maximum? A minimum. And why is that? Because it opens up. It's at the bottom. It's the lowest point you could ever go. So we could tell, just by looking at our equation, that this graph was going to open up. How could you tell that? Do y'all remember our A value? Since it's positive, that means your graph is going to open up. So as long as your A value, your leading coefficient, is positive, your graph will open up. So it's going to have that regular U shape. What happens when that A value is negative? You open down. So it's going to be like that N shape now instead. Do you remember what happens when that A value was a number that's bigger than 1? If it's bigger than 1, it's kind of opposite of what you think. It makes it skinnier. So you have a skinny graph. And what if that A value is less than 1? If it's a fraction, makes it wider. Is that okay? All right, there was one other thing that we talked about yesterday that we haven't mentioned yet. That was your axis of symmetry. You remember talking about that? It's like that imaginary line we could fold it on and it'd be the same on either side. What was the formula that helps you get there? Do you remember? negative b over 2 what? A. Good. So the axis of symmetry, that was the x value of your vertex. And again, that formula is going to help you get there. We could sketch in where we think that's going to happen. It's probably going to be somewhere in here. This one's not as nice as the ones we were doing yesterday. It's a little off, because if you looked at our table, the values didn't repeat like we were used to seeing yesterday, so it's a little harder to tell. But that's okay, you'll have some like that sometimes. Questions on any of that stuff? Is it coming back to us, remember, from yesterday? Yeah? Okay. So we're going to find zeros from your graph today. So we did that algebraically earlier this week when you were factoring and solving. So this is going to be a different way to do that. So remind ourselves, what is a zero? If I ask you to find a zero, what does it want? Or where it crosses the x-axis. What are other words that they might use? Roots. What else? Solutions. What's the last one? X-intercepts. And we said that's where you cross the x-axis. So there are only 3 possibilities for how many zeros you could have when you're graphing them. Do you have any guesses what they might be? I'll just tell you what they are and then we'll guess from there. So you can either have 2, like we did up here. You can have 1, or you could have none. So if you have 2 roots, what is your graph going to look like? Do we have a graph on our page that has 2 roots? Yeah, so if it's got 2 roots, that just means that it crosses twice. Yeah? Doesn't matter if it opens up or down. It's just got to cross your x-axis twice. That would give you 2 roots. Is that okay? So what if we only had 1 root? What do you think that would mean? What do you think? It does what? It's like, no, it's still a quadratic, so we still have a parabola, but it's only going to hit or touch once. I don't know, what do you think? Do you want to try to draw it? Beautifully stated. The vertex is on the x-axis. Do we know what that means? Is this vertex on the x-axis? Is it above it or on it? On it, so it could look like this. So it's going to bounce and go back, right? It's going to touch right there. Yeah, yeah. So that's going to be 1 0. So what if you don't have any zeros at all? So it could be above it or below it. Or beside it. It's going to go on forever. All right, so if it was below it, what would it have to look like? Would it still open up? It'd have to open down, right? So I'm going to put that over here as well, just so we remember. It'd be totally below it and it opened down. You would have no zeros there. Is that okay? Because if it was below it and it opened up, it'd cross twice. Okay. Y'all ready to start graphing some more? Okay, cool. So let's do this. We're going to use our graphs or our calculators only a little bit today. We're going to try to do as much as we can by hand. So if we need to graph this guy, it's helpful to start with your axis of symmetry, or like your vertex. So we need to use that itty bitty little formula to help us get started. So what is that formula that helps you find your axis of symmetry or your vertex? So again, you're writing that every time until you've got that memorized. So we're going to say negative b over 2a And what is our b value? So we'll have -2 over 2 times a, and what was a? 1. So you've got -2 over 2, and what is that? -1. So we already have our axis of symmetry. We're done with that, yeah? So I'm going to say axis of symmetry, and how do we write it? X equals -1. So we can go in, and I'm going to use a highlighter for my axis of symmetry like we were doing yesterday. If you want to do that, you can. If you don't, that's okay too. And at x equals -1, I'm going to go ahead and draw that dotted line, because that's where we're going to reflect things across. Does that make sense? So then once you have the axis of symmetry, or the x value of your vertex, how do we get the y value? Plug it back in. So you're going to have -1 squared plus 2 times -1 minus 8. So what is -1 squared? 1. And what's 2 times -1? -2 minus 8. What is 1 minus 2? -1 minus 8. -9. So how would we write our vertex? -1. No, good. So we can plot that. -1, -9. We also need zeros, and we need our y-intercept. So I'm trying to think how we want to do this. Do you want to do by hand as much as you can? Yeah? Is that okay with y'all? Try that? I think y'all can handle it. So if we want to find our zeros, how do you do that by hand? Do you remember? Set of equal to 0, then what? Factor. So x squared plus 2x minus 8 equals 0. Then we've got a factor. So we're going to try to drop it low because there's no GCF that we could pull out there. What do you drop first? What do you always keep? First sign. Second sign's a minus, so what does that mean? Opposite, so we need a minus. What are factors of 8 that subtract to be 2? 4 and 2. Once you factor, what do you do? Set your factors to 0 and solve. So when we say x plus 4 equals 0 and you solve, what do you get? X is -4. When you have x minus 2 equals 0, what do you get? X equals +2. So those are where we cross the x-axis. Do you agree?
Yeah.
Okay, so I'm going to go to the x-axis and put a point at +2 and put a point at -4. So we've got those. And we can go write our zeros. I want to write them as ordered pairs. So how would we write -4 as an ordered pair? How would we write that zero? Okay, -4, 0. And then what about the +2? Is it 0, 2 or 2, 0? 2, 0. Good. All right. So we've got some good points. How could we get some more to fill it in? Okay, look it up in the calculator. That's what we're going to do. If you didn't have your calculator, what could you do? Plug in some points, right? So you could plug in like 1 or -1 or -3 or +3. Just plug in stuff to get points, right? That's what our table is going to give us in our calculator. So let's go ahead and graph this. Before we start graphing, do you think it's going to open up or down? We can already tell, right? Because you've got zeros here and here, and it looks like your minimum is going to be about here. How could you tell from the equation that it's going to open up? Because that a is positive. Good. So let's graph this. We've got x squared plus 2x minus 8. So there's our graph. We need points. How do we find them? Control T. So what are some good points that we can put on here that we don't have yet? 1, -5. What else? 2, 0, we've already got. We could do 3, 7. What about some negative stuff? We need some stuff on the other side of our axis of symmetry. If we had a point at 1, -5, where would it be on the other side of that axis of symmetry? On the other side of the axis of symmetry. It's like looking really, 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 really close here, y'all. So you've got how many blocks between the points? 2, -5. So then go 2 over. Yeah. So if it was 2 blocks here, we'll go 2 blocks here. That'll be -5. Is there a point for -1? We already had -1. What about 0? 0, -8. So then would we have a point on the other side of that axis of symmetry? That would be -2, -8. Yeah? Are we kind of getting how that works? Do you have questions? You can just pull all these straight from your calculator, so if you're confused by that, it's not a big deal. And then because we had a point up here at, what was it, +7, it was 1, 2, 3, 4 blocks away, so we'll go 1, 2, 3, 4 blocks away over here and have another point. So everything's just like reflecting over that axis of symmetry. So now we have a really nice parabola going on there. And we can connect our dots, make sure it's that smooth U shape. As smooth as we can get anyway. I say that and mine was awful. Is that what your calculator says? It should be -4, 0, -5, 7. So the only thing that we're missing here now is our y-intercept. Now we didn't talk about that a whole lot yesterday, but where would your y-intercept be? Where you cross the y-axis. So look at your y-axis. Where do we cross? Where? Are you sure? We had a point at 0, -8. So -8. Yep. So how would you write that as an ordered pair? 0, -8. Questions? Did I lose anybody on that? Yes, no, maybe. Okay. So we're gonna go do the same thing. So on the next one, we're only gonna find the vertex and axis of symmetry by hand. We'll do the rest in the calculator. Does that sound okay? Yeah. All right. So to find your vertex and your axis of symmetry, what little formula do you use? Negative b over 2a. So what is our b value? 0. So you're going to have -0 over 2 times a. And what is a? 1. So 0 over anything is going to give you what? 0. So your axis of symmetry is what? Is it just 0? X equals 0. So we could go put our axis of symmetry, our dotted line at 0. X equals 0. Again, you don't have to do that if you don't want to. And then your vertex, how are we going to find that? Plug 0 into where we started. So 0 squared minus 4. What is 0 squared? 0. And 0 minus 4 gives you? -4. So our vertex is going to happen at 0, -4. So we can plot that point. Alright, so we'll put it in our calculator and graph it to get the rest of our points. So we're in x squared minus 4. And how do you pull up your table? Get all your points? Control T. And what are some good points that we can plot? 1, negative 3. What else? 2 what? 2, 0. 3 what? 5. Make sure that you have typed in x squared minus 4. So it sounds like somebody just has x squared in there. That's why your answers are not matching up. So we've got all these positive numbers. Since our axis of symmetry is at 0, what do you think that means? Can we just reflect all these over? Yeah. So instead of having positive 1, negative 3, you're also going to have what? Negative 1, negative 3. And then instead of crossing it positive 2 over here, you're going to cross that where? Negative 2. Do y'all see how these points are just reflecting over that axis of symmetry? That's why we find that. That makes this a lot easier, right? Because you can find half the points and just reflect them over and you're done. And our top point up here, we were 3 blocks away, so we can go 3 blocks the other direction. And there's our last point there. Is there anything else that'll fit? No, the next one goes off. Your vertex? 0, negative 4? Is that what you're, no, you asked x-axis, 2 and negative 2. Yeah, you're just pulling these from the calculator. Yeah? So once you've got those points, you can connect them. We'll have our parabola going on. That one looks pretty good. So where are our zeros at this time? Negative 2, 0. Where else? 2, 0. What was our y-intercept this time? So 0, negative 4. Is that okay? Questions? Alrighty, on to number 3. So we've got, this time you've got negative x squared minus 2. So just looking at that equation, is it going to be very similar to what we've just done? Kinda. What's going to be different? It's going to open down. Yeah. So we got to find our vertex and our axis of symmetry first by hand. So what's the formula to help us do that? Negative b over 2a. So what is our b value? So we've got negative 0 over 2 times a. What is a? Negative 1. So 0 over anything is going to give you what? 0. So our axis of symmetry is x equals 0. And that's the x value of our vertex as well. How do we find the y value? Plug it back in to what they gave us. So we're going to have negative 0 squared minus 2. And what is 0 squared? If you make that negative, does it really do anything? No, so it's just 0 minus 2, which gives you what? Negative 2. So our vertex is at 0, negative 2. So we can go ahead and sketch in our axis of symmetries again at x equals 0. So we'll do that dotted line on the y-axis. Our vertex is at 0, negative 2, so we'll put a point there. Then we can get some points from your calculator. So go to a new graph, and what are we typing in this time? Minus 2. And Control T is going to pull up your table. What are some good points for us? 1, negative 3. 2, negative 6. And 3 goes off and 4 goes off. So could we reflect these points over? So from 1, negative 3, we reflect that over, you'll have negative 1, negative 3. And then from the 2, 1, if we count 2 blocks over, There you go. So where are zeros this time? Do we ever cross the x-axis? Okay. So this one is for zeros, we'll say none, and that's okay. What about our y-intercept? 0, -2 again. Questions? Anything we're not sure about, don't quite understand? Are we noticing anything yet? Okay.
If you're when the b is 0, it's just seeing like your like on the last one, it's like
Your b was 0, so your axis of symmetry was 0.
the thing is, what's it called? The y-intercept is like 0, -2. It's the same as the same as c.
Okay, so she said the y-intercept is the c.
Yeah, and it's like on the
It was like that here too. What about the first one we did? So even though your axis of symmetry changed, your y-intercept is still your c value, yeah? Was that true for the first one that we did?
Yes.
Did we cross it +2 on your y-axis? Did we? I don't know, I didn't. I think we had a point there. Maybe we didn't. We should have had a point there. I think we did. I had a point there. Did I have a point at 0 too? So what could we say about that c value? What's your y-intercept? So every single time, your y-intercept is going to be the c value. Let's add that to the top of our page so you've got it. All right, y'all ready to do the last one? Please try to curb your enthusiasm. So looking at number 4, just looking at it, which way is it going to open? Up or down? Look at number 4, which way is it going to open? Going to open up, how do we know? Because A is positive. What else can we go ahead and find right now? Your y-intercept, where's it going to be? 0, 9. So we can go ahead and plot that. 0, 9 is going to be our y-intercept. Okay, let's find our axis of symmetry. What formula helps us do that? -b/2a. What is our b value? So we'll have -6/2 times a. What was a? 1. So you've got -6 divided by 2. What is that? -3. So for our axis of symmetry, what are we going to put? X equals -3. So we can go plot that, or draw that dotted line at -3. How are we going to find our vertex? We know the x value is -3. We still need to find the y. So what are you going to do? Plug it back in. So we've got -3 squared plus 6 times -3 plus 9 What is negative 3 squared?
9.
What is 6 times negative 3?
Negative 8.
And then we got plus 9. So what is 9 plus 9? And 18 minus 18? 0. So your vertex is at negative 3, 0. So we can plot that negative 3, 0. Is that okay? Alright. So let's get some more points for this. So we'll put it in our graph and see what else we can get. Can you plot another point right now? What could you go ahead and get? We had 0, 9, right? On this side of our axis of symmetry. So could we count it over to the other side as well? So we're 1, 2, 3 blocks off. So keep counting. Go 1, 2, 3 more. Does that make sense? Do y'all kind of get what I'm saying with that? Yes, so, maybe. Yeah? Can I get like a head nod, something? Okay. And so we're typing in our new graph. We got x squared plus 6x plus 9. What are some other points that we could plot? We got 0, 9. What could you do for negative 1? Negative 1 gives you what? Look in your table. 4. Negative 1, 4. When you plug in negative 2, what do you get out? 1. So negative 2, 1 is a point. Then you could reflect those two over, so you don't even have to keep scrolling in your calculator. So 1, 2 here. Then connect your dots, and we're all done. Questions? I'm sorry? Do you want to factor this one? I can't hear what you're saying, number one. But also, we just haven't written our 0 yet. What is our 0 for this one? Negative 3, 0. And we just have 1, because it just touches and goes back, right? So when you have x squared plus 6x plus 9, and we factor that, what does it factor into? Have I done that yet? Or can you look at it and tell? If you want to factor that, you'll set up your parentheses, drop your x's. What do you always keep? Second sign's a plus. What does that mean? Same. You need factors of 9 that add to be 6. 3 and 3. So when you solve this, what do you get for x? And then when you solve this, what do you get for x? Negative. So it's the same answer. So when that happens, when you have a 0 that happens twice, if you say that has a multiplicity of 2, which is not something that you're going to have to deal with till like math 3, okay? But that's why it just bounces and goes back up. That's why you only have 1 0 there, because it's the same number twice. Yeah. Does that answer your question, Haley? Or are you still not? Yeah. Are we okay? Anything else we need to talk about? We okay? All right. So that's all we got for notes today. And we're still practice, I think.